Welcome back to the Deep Dive. Today we're putting on our virtual hard hat, you could say.
Yeah.
We're diving into a source stack that a listener sent over, really fascinated by, well, the future of building fast. We're looking at modular structural aluminum construction tech, specifically training materials from a company called MHS Building Systems.
Right.
So our mission today, it's pretty critical. We're not just reading specs. We need to really get the core technology, understand how it claims to be so fast and simple to put together.
Yeah, the how is key.
And maybe most importantly, take a hard look at the structural side, the integrity, the code compliance for this patented post and beam system they have.
Yeah.
It's definitely challenging wood and steel, so does it actually stack up?
It's definitely an interesting space. And MHS, well, they've been working on this for a while, over 2 decades in this specific modular aluminum niche.
Okay.
Their whole identity seems built on 4 things: strong, lightweight, sustainable, and certified. And that last one, certified, that's really important. They've got QAI CIRRUS 139 certification.
QAI CIRRUS. Okay, what does that mean in practice?
It means they meet the big U.S. building codes, IBC, IRC, CBC. So yeah, it's signals this isn't just some idea on paper. It's verified for Type V construction, residential, light commercial.
Okay, let's unpack that. Type V construction, just so we're all on the same page. This basically standard wood frame houses, right? Low-rise homes, smaller commercial buildings you see everywhere.
Exactly that, yeah. If they're genuinely competing in that huge Type V market, then yeah, they're definitely serious. So the design principles. What makes this MHS system different from, say, other aluminum framing out there?
Good question.
It really seems to boil down to simplicity. Structural simplicity, modularity, and using just one main material, 100% aluminum.
That 100% aluminum part, that hits the green notes right away, doesn't it? Means it's all recyclable, reusable when the building's life is over.
Totally. Big sustainability point.
But beyond the material, how is the actual structure engineered? How's it strong?
Well, the strength comes from 2 things: the specific alloy they use and the shape, the geometry of the parts. They use 6061T6 aluminum alloy.
6061T6. I've heard of that. Isn't that used in like high-end bikes and planes?
Precisely, yeah. High performance stuff, bike frames, marine structures, aerospace. It gives you a really excellent strength to weight ratio, meaning you can handle big loads with components that are much, much lighter than steel. And crucially, their system is specifically engineered, they say, for high seismic zones and extreme wind loads. They've got the testing data to back that up.
Right, that strength to weight thing. That must be a huge deal for just getting materials to site, foundations, all that. But okay, versatility. The sources say you can build almost anything with this. What kind of range are we talking about?
The modular nature makes it super adaptable. You can use it for, well, accessory dwelling units, ADUs, which are popping up everywhere now.
Oh yeah, huge demand for those.
Right. But also larger prefab modular buildings, classrooms, office pods, even things like mobile trailers or shelters, structures for trade shows, event spaces, even frames for solar panels.
Wow, okay, so the core frame is the same basic idea, just scaled and configured differently.
Pretty much. The core components connect the same way, but you can integrate different things into it. And there's an aesthetic point, too, mentioned in the materials.
Ah, yes, the modern look.
Exactly, that clean, modern aesthetic. It seems architects can choose to leave the frame exposed as a design feature, or they can hide it. That flexibility is designed right in.
Okay, that leads us neatly into the mechanics, the nuts and bolts. Because this is where it gets, well, really interesting for me. Speed is the big promise, right? And normally, construction speed gets killed by needing specialist trades, concrete curing, safety stuff around welding, hot work. MHS says they eliminate a massive bottleneck.
That's the absolute core innovation, yeah. No field welding. It's protected by their U.S. patent, apparently. The whole structural post and beam frame uses only mechanical fasteners. Bolts and clamps, basically.
But a sophisticated clamp system, right? Not just wing nuts.
Definitely not wing nuts. It's an interlocking clamp and flange system. And here's the clever bit. The clamps have adjustable opposing jaws.
Adjustable jaws. Why is that important?
Think about a real construction site. Nothing's ever perfectly level or straight, right?
Huh. Tell me about it.
So this adjustability gives them tolerance control. It means you can adjust things structurally during field fitting, get things aligned even if the foundation is slightly off, or a beam has a tiny imperfection. Saves potentially days of fixing things.
Okay, I see. And using only mechanical fasteners. that bypasses needing certified welders on site.
Completely. No expensive field welders, no fire watch, none of the safety protocols you need for hot work. It's a cleaner, faster, arguably safer process on site.
That sounds like a major shift in cost and complexity.
Right.
You move the really specialized skill welding from the field back to the factory, potentially? Makes the site work simpler?
That's the idea.
But, okay, strength. We talked about the alloy, but construction needs serious load capacity. Can a clamped aluminum joint really hold up a roof, handle wind, snow, everything?
Absolutely. And this is where their testing and certifications become critical. You have to look at their two main product series. The real workhorse is the MHS 170 series.
MHS 170, got it.
It's their heavy structural part. It measures 6.69 inches square, so pretty beefy. It's tested to ASTM standards B221 and B557, which are tough material specs. And the results, they're compelling.
Okay, give me the numbers. What can it handle?
Each connection point using the MHS 170 series is rated to support structural loads up to 15,000 pounds.
15,000 pounds per connection.
Per connection. To give you some context, that's way higher than a typical connection in standard wood framing. Gives engineers a big safety margin. And for resisting side-to-side forces like wind or earthquakes, shear resistance, a standard 12-foot by 10-foot shear wall built with this system, rated for 25,000 pounds.
25,000. Okay, that verifiable load capacity is obviously why they got the code compliance sorted. That's not lightweight framing at all.
Not at all. It really changes how you might think about engineered aluminum. They also have an MHS 150 series, which is a bit lighter.
Okay.
Used more for smaller internal structures, maybe non-load bearing walls, furniture frames, things like that. But it uses the same core clamp system, so it all integrates.
So you've got the strong, certified aluminum skeleton snapped together with these adjustable clamps, but you still need walls, a roof. How do you enclose it?
Right, the frame is designed to work smoothly with SIP's structural insulated panels.
Ah, SIPs. Heard good things about those too.
Yeah, they're great. High-performance building panels, basically rigid foam insulation. They specify a 4.5-inch EPS core sandwiched between two structural boards. You get insulation, strength, and fast installation all in one go, much quicker than framing, insulating, and sheathing separately.
And how do they fit?
The MHS frame is designed so these SIP panels just slot right into the beam and column channels for walls, for the roof. Makes for a really quick way to get a sealed, insulated structure up.
Okay, we've confirmed the skeleton's strong, the SIPs fits nicely. Let's think about the actual job site now. It sounds, well, less like traditional building and more like assembling a giant high-precision kit almost.
That's a good analogy, yeah. And the contrast with stick building is pretty stark. You know, with wood, you wait for the foundation to cure, then weeks of framing, insulating, sheathing.
Right, separate stages.
Here, the structure and the thermal envelope go up almost together. It's a standardized 6-step sequence they outline for their authorized builders.
Okay, walk us through it. Step 1.
First, set the base anchors. They use specific MHS steel foundation fixtures for this. Getting that base perfectly aligned is critical for everything else.
Makes sense. Step 2.
Install the columns. These are the MHS 170 posts, the vertical pieces. They just drop onto the anchors. Third, add the horizontal beams using those interlocking clamps we talked about.
Okay, click. Step 4. This sounds important.
Step 4 is very important, and it ties into quality control. Tighten and align all the joints. But crucially, you have to do it precisely according to the torque standards MHS provides in their manual.
Ah, using torque wrenches.
Exactly. This isn't guesswork. Getting that torque right is what ensures the connection meets its structural rating. Fifth step, integrate the SIP panels. They usually come pre-cut, so they slot in quickly.
Nice. And the final step.
Step 6, install the caps and corner covers. These seal everything up against the weather and give it that clean, finished architectural look.
That process sounds incredibly efficient, but it raises a flag for me. If the whole structure relies on these mechanical fasteners, the quality control, the QC, has to be absolutely bulletproof, right?
That's an excellent point, and the source material really hammers on this.
How do they make sure every single one of those bolts hits the right torque? Especially on a big commercial job with maybe thousands of connections?
They mandate strict adherence to their MHS QC manual. It's not just visual checks. Authorized builders have to inspect the extrusions for straightness and cut accuracy before assembly. Then they have to meticulously log the torque applied to every single structural fastener.
Log every one. How?
Using calibrated torque wrenches. And they even require photo documentation of all the fabrication steps, especially those connection points.
Wow.
It's a level of traceability that's designed to give engineers and inspectors maximum confidence. It's probably way beyond what's typically practical on a traditional wood frame site.
So the QC focus shifts, doesn't it? From judging visible stuff, like is the wood straight or is the weld good, to documenting technical performance, the torque number.
Exactly. It's a different process for the construction teams. Requires real discipline on site.
But the payoff is predictable performance and maybe faster final sign-offs because you have all that data ready.
That seems to be the goal, yes. Verifiable performance documented upfront.
Okay, let's shift to the business side a bit. Logistics. If I'm a designer, maybe a custom home builder, and I'm interested, what's the supply chain like? How long does it take to get this stuff?
Well, it's a specialized system made in a factory, so there are lead times. The standard lead time they mention for the extrusions, which come FOB Long Beach, California, is currently about 2 to 3 months.
2 to 3 months. Okay, so you need to plan ahead.
Definitely requires careful project planning.
Yeah.
But the flip side is, once those components arrive on site, the actual structure can go up incredibly fast compared to traditional methods.
Right. And that speed connects to their business model, doesn't it?
Yeah.
It's not just about selling aluminum parts. It seems like they're licensing a whole system.
Exactly right. This isn't like a big national home builder doing everything themselves. MHS focuses on granting exclusive regional rights.
To who?
To authorized fabricators, builders, and designers in different areas. They provide the standardized, proven tech, the engineering support, the QC standards. And then the regional partners handle the local customization, assembly, finishing, using that core system. It positions the technology for potential global reach relying on these partners.
Okay, so let's try and wrap this up for the listener. What's the big picture here if we distill this deep dive? MHS offers a certified, strong aluminum construction system. It's built for speed using high-performance 6061 T6 alloy. It offers architectural flexibility.
Yeah.
And the absolute key innovation seems to be that patented interlocking clamp system. That's what ditches the field welding and swaps it for precise, documented mechanical fastening.
Precisely. And the implications. They go beyond just building faster, don't they? If construction can be this modular, this fast, and this is a big claim, 100% reusable, like they say.
Right, the reusability factor.
How does that start to shift the economics, the design thinking, for custom homes, for commercial buildings in the future?
It completely changes how you might value a building component, doesn't it? Instead of wood studs being basically disposable, one-time use. If you have an aluminum frame that can genuinely be taken apart, shipped somewhere else, and reused, that challenges how we think about materials over the entire life of a building.
Yeah, the whole life cycle thinking. If the main structure holds its value, if it can be moved or reused, then the initial material cost, which, let's be honest, is probably higher for engineered aluminum than basic lumber, maybe starts to look more like a long-term asset.
Interesting. Less depreciation, maybe.
Could be. It certainly pushes the industry towards materials that align better with sustainability goals. And by licensing this regionally, MHS is betting that there's a global demand for this kind of standardized, proven, reusable building technology. It's a fascinating shift from purely local building methods to a potentially global engineered system.
Definitely food for thought. If you're aiming to build the future together, like MHS puts it in their materials, maybe the materials themselves need to be ready for disassembly and a second life. Something to consider next time you pass a construction site. That's our deep dive for today.